Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
Okay, so in the previous video tutorial 117, we actually compared the results of our random forest regression model with our multiple regression model. Remember, we did the random forest model within Earth Engine, and we extrapolated the results thereof, and we entered it into our QGIS using the coefficients. And we also then did a multiple regression model in QGIS, and we compared the results of the two models, and tentatively and anecdotally, it seems to suggest that the random forest model outperforms the regression model quite significantly, if I may say. And we did a visual comparison, etc., etc. So, yeah, so you can see that there is the random forest model that we generated using the random forest regression method, and there is the multiple regression using QGIS, and that's the actual NDVI for our region of interest. Again, there's the results of my regression modeling, and there's the results of my random forest modeling. And as I said, visually it looks like random forest by far outweighs or outperforms, let me put it that way. Outweighs is not the right word. Outperforms. So I thought, let's play around with that now. Let's continue with that now. So within Google Earth, within QGIS, there's unfortunately not many types of regression modeling available. Similar with QGIS, I don't think there's some options that's not available in Earth Engine. So as I said, remember the random forest one we did in Earth Engine, and the multiple regression one we did in QGIS. But we were able to consolidate the two images within QGIS and do a comparison. Okay. But there is definitely a number of additional regression methods or models that we can apply, and let's see what the results they produce, and we can build up, let's call it an inventory of regression modeling, and then we can compare these models visually and statistically to see within our region of interest, within NDVI, which yields the better results. And we keep our basic formula the same, meaning NDVI, dependent variable, and three explanatory variables being elevation, rain, and temperature. So we keep that four variables constant, and we just play around with the methodology or the methods. So what I then decided to do is, let's go and have a look in R, because in R there's many options that we can run there. There's no shortage of options that we can run here. So let's play a little bit of in RStudio, because remember, I always keep on telling you that we start in Earth Engine. Okay, that's our big daddy or big mama, if you want to, however you want to express it. Okay, so from there everything runs, whether it is images, whether it's data, whatever the case may be, everything runs from Earth Engine. So then, as I said, I normally run it then in Excel, in QGIS, in RStudio, and in Geoda. Because they all complement one another. So what this one may not have, or is not too good in that one, may excel in, and vice versa. So I work in that suite of options to yield a variety or diversity of options and results. And the nice thing is they are all free available. You don't have to pay for any of those options. So that makes it even more worthwhile. Okay. So remember, we had our normal standard multiple regression, NDVI, elevation, rain, temperature, and the data set that we're using. That's the one that we've generated our multiple regression. If you can remember, that's it there, 6.51, etc. So that's the results of our multiple regression as from QGIS. Okay, that's from QGIS, and we get exactly the same in RStudio. See, 6.521, 6.521, etc., etc. So the results that we obtain within QGIS in our multiple regression, and the results that we obtain in RStudio for multiple regression is exactly the same. No difference to it. They remember the R square 0.44. Now within RStudio there's a lot of things that we can do with it, but let's ignore that for now. Then there's a package within RStudio. Okay, there's a package within RStudio which are called mass. This one here, mass. Okay, that package there, let me just go back to, I've installed that package. Okay, now that package gives you options to a number of regression models. Okay, so if we open the R package, mass, it's a manual. Okay, so just search for R package mass and go and look at manual, and you'll see all the ins and outs of that package in this specific model, in this particular manual. So if we go back to our RStudio, the first one which we're going to do is RLM. Okay, you'll see our equations still stay exactly the same. We use the same database, and this is just a factor that we're working in. So if we go to RLM, let's see what the manual says about RLM. So if I go there, let's go to RLM. Oops, sorry. Come on. We go to the index and we go and search for RPQR. There's RLM 125. It's robust fitting of linear model. So this is a robust regression model using an M estimator. There it is. It gives you the K2. It looks like it's a standard value. There is the method, arguments, the weights. So it does use weights. The data, X and Y method. You can read through all these ones. Weight, social tests, etc., etc., details. Okay, but this is, yeah, so this is it's a robust regression using an M estimator. Okay, so there it is. Okay, so let's go back to our R and let's run that one there. So we're going to run it and we're going to generate the coefficients, and there it is. So it gives me the following coefficients. There's my intercept, my elevation, my rain, and temperature. Okay, it's got 10 iterations. Scale estimate, and not intercept. I'm going to copy that, and we're going to enter it into my. I'm going to enter it into Excel. So all I'm going to do. Now this is unfortunately a bit of a time-consuming exercise, but it gives you an idea what we can do. So I'm going to go cut. I'm just going to put the coefficients below one another, and come on, and just want to make sure it is elevation, rain, and temperature. So it's elevation, rain, and temperature. Okay. So what we're going to do here is, first of all, I want to get rid of these annotations. Okay, so I'm just going to go and format, and then I'm going to take the commas after dots away, and I'm going to place it with commas. Okay, so now it's in that my Excel format, and I'm going to go format cells, and I'm just going to go give it that one there. So I'm going to take, so now it's, the values are gone. Okay, so let's just quickly do that, copy, and then paste it as that. Oops, doesn't want to. Okay, so now the values are gone, so I'm just going to copy it again and paste special. Okay, so let's do this, copy. I just want to get away from this okay, so it doesn't, why doesn't it want to do that now? Let's do this one. Yep. Okay, so let's leave it. I'm not too concerned about that. Okay, so we're going to write it in this format. So I'm just going to copy this formula. Remember, this is the raster calculator. This is the formula that I used in my previous raster calculator. So I'm just going to enter these values within my formula, and I'm going to copy this into my raster calculator. Okay, and remember, I need to take away the commas and replace it with dots. So this is positive. So here elevation is actually positive. Now previous one elevation was negative. This was rain, so rain is positive. Yep, rain was positive. And then this is temperatures, and temperature is negative. Oops, crazy. So let's copy that. And come on. And then I'm gonna put it in there. That is my formula. Just make sure it's 7.2, then it's 0.0064, then it's 0.0046, and then it's minus 0.2. Okay, so that's my robust regression coefficients. So I'm going to copy that, then I'm going to go back into my my QGIS, and I'm going to go to raster, in raster calculator, and I'm going to copy that formula within my calculator, and then I'm going to go and save it in my project folder. It was the NDVI, so we'll continue with NDVI. Let's quickly go and have a look. NDVI, where is it now? NDVI. So let's NDVI prediction. Why can I prediction? There we go. NDVI prediction, and I'm gonna go. This is a what did you call? What's it now called in R? It is RLM prediction, RLM, and we're gonna go save. Everything is okay. Oops, I need to make it dots. Remember the dots. It doesn't want commas, it wants dots. So let's quickly just remove all the commas, and we change it into, come on, into dots. Now there you see, now the OK button is activated, and we press run. So let's see what that happens now. Okay, so normal, we do our colors. Just let me see, what did I use? Did we use the quantile? Yes, we did use the quantile method. So I'm going to go to properties, I'm going to go single, choose the colors, and I'm going to go quantile, go classify, press apply, and there we go. So that's my robust regression. That's my robust regression. That's the actual, and there's my robust. There's the actual, my robust. Let's compare it to my normal multiple regression. Hello, there's my normal multiple regression, there's my robust. My normal multiple regression, there's my robust. Let's select them all, and let's use the inspector. Let's use any place here. Let's use that place there. So there is my actual values, 0.53. There is my random forest, 0.47. There is my multiple regression, 0.37, and there's my robust, 0.38. So it's still not as good as the random forest, but it's much better than the normal multiple regression. So that's interesting. So let's quickly go to the next one. And I'm not going to do all of them, but it gives you an idea. So let's use the LQS method. So let's run that, see what that looks like. Some of them do take, so there is the coefficients for that one, which we're also going to take. Now, let's quickly LQS. Let's see what LQS is. I'm going to go to my index again. let's go LQs. There it goes. There's LQS. Go with the 30. Let's go down. Resistant regression. So the previous was robust regression. This is fit the regression to the good points in the data set, thereby achieving regression with a high breakdown point. Okay, whatever that means. Default intercept LS control. Okay, arguments. We can read for this. Anyway, so this is a resistant. So let's see what that looks like. So I'm going to copy again the coefficients, and I'm going to go to my Excel. I'm going to copy them in, and I'm just going to quickly do that again. Same, paste it in here. In fact, we don't have to do that because now it's not in that weird notation. It's in a proper notation. So I'm not going to change the commas. I'm just going to leave it as is. So I'm just take my formula and I'm going to say copy. I'm going to go paste here, and I'm going to go. So this is quite large compared to the well, it's not too large. So I'm going to change it there, and I'm going to take this one. So that is elevation. So again, positive with elevation. And then that is rain, interestingly, is now negative. Oh, come on. Rain is now negative. That's weird. Let's just confirm. I just want to confirm this. Rain is negative. Temperature is negative. Okay. If it says so. Let's go and have a look and see. Copy. And I'm going to enter it in there. And then there's my equation, my formula. I'm going to copy this, and I'm going to go to my raster calculator. I'm going to paste it in. And why is it not so? Okay, I must give it a name. And it is LQS. LQS. So it's called LQS. Let's quickly. Okay, so let's press it. There we go. LQS. So let's go properties. We go zero color. We go quantile, classify, apply. And there it is. Let's have a look and see. It looks already much better than the robust one. But let's anecdotally just select these ones, and that point there. Okay. So there's the actual value, 0.58. The random forest, 0.47. The multiple regression, 0.37. The robust, 0.38. And the QLS, 0.41. So this is getting better. So this is actually a much better. So let's remember to save. So the QLS is actually not too savvy. Now there's a LQS. There's another one here that's using the LTS one. Oh, so okay. So we must use LMS. Let's see in the manual what LMS is. Let's see if there's a place here where we can. There's LMS. Yeah, no, it doesn't. LM doesn't have an LMS. It has a QIS, and then within this, it specifies. Okay, so that's where it specifies. Where is it now? Come on. Yeah, here it specifies. See, there's the LMS. The LM is the LTS, LQS, LMS, and S. Let's have a look and see. Okay, so those are all QLS, and the other two are robust ones. I'm not going to go for all of them. I think you get the idea. I think you certainly get the idea of what we're doing here. So that's generating a number of regression equations based on different methods, and as I said, we can then generate the coefficients of those models, and then the coefficients we can then use within QGIS to generate images, prediction images, and then we can visually and statistically compare which image or which prediction model or which regression model gives us the superior results. We can rank them, etc., etc. So let's have a look and see. We can do this one here, LQS. There it is. Also interesting, it's got a -1. Let's have a look at this one, method MM. There is method also, and that I think that the LTS we haven't done. And there's the LTS. Interesting, these lines all gives rain a negative coefficient, temperature, elevation, which is interesting. Anyway, yeah, so go and have a look, play around with these. There's a whole lot of models that we have. So we've basically generated a random forest model. We generated a normal OLS, multiple regression model, and then we generated these multiple regression models based on these methods, the robust methods and the LQS methods. Then I've also generated a support vector regression model. Okay, if I go up here, a support vector regression model within RStudio. So there it is. So I'm using the SVM methodology, and that comes from the package E1071. This package here, this library package here, you use to generate support vector regression models. Okay, so support vector regression within R. I think they say the package, they put it somewhere where it is. Yeah, there's the package. Okay, so this package E1071, that can be used to generate support vector regression models. Okay, so I'm not gonna do that for now. Otherwise, let's keep that for our second or follow-up video tutorial. But just to tell you that besides all this, we also can generate support vector regressions using the SVM. Okay, so there it sits. Okay, and we can do a prediction of it. Okay, so there it sits. Then we can also generate a, let me not go there. We can also generate geographically weighted regression, and I've started with that. Then we can also generate spatial regression, and in spatial regression there's again a whole lot of models that we can generate. Okay, so there's no shortage of regression methodologies without spatial elements, and with spatial elements, with weights, no weights, etc., etc. Okay, so let's park the other methodologies or the other methods or models. Let's park that for a follow-up tutorial. Video tutorial. Let's conclude with this, in the sense that we've now generated 2 additional images, prediction images, using the robust and LQS methodologies, and we compare it, and so far the random forest still is the lead contender, or the lead horse, so to speak, with the other 3 getting better and better as we proceed. So let's for now just end the video tutorial for there. We will be back. We will continue with the rest. Let's park it there, and thanks so much for joining me, and thanks so much for participating and sending me comments. I really appreciate your comments and your feedback. It helps a lot. And yeah, please remember to subscribe. We're chasing those magical numbers, so please remember to subscribe and share and like, press those buttons, and I'll see you on the other side.